Hi, this evening. Corey Ackley, Hammer Silver Performance, or HSP, is I reference it often. So last night I sort of made a little video discussing, hey, who is Corey Ackley? In that process, there was also a discussion on head flow, and what I want to do is follow up with that with a little bit more detail and data. So, a disclaimer I'm going to make is twofold. First one is that I realize this video probably does not appeal to the masses. And so if you're not into some of the finer details, when we talk about, again, valve timing or head flow or those other kind of things, you may not have any interest in it. But with that said, you may, take away something from there as well. The other piece of this is no, I'm not a head expert. Yes, I've done some, port work and things like that. I did buy a flow bench a couple 3 years ago, and it was a small Superflow 110, and I got a little bit of work out of it before it crapped out on me, and those are non-rebuildable, so that sort of fell by the wayside. But with that being said, I just wanted to sort of share those two things. So another thing I also want to talk about is, for those who are in this type of stuff, I would ask you to think back, whether you're reading a Hot Rod magazine or if you were reading Muscle Mustang, Super Ford, something like that, or if you're a fan of Engine Master Challenge on Motor Trend, or Richard Holdner on YouTube. What they do is they all those organizations and magazines have all done some type of head shootout where they take a base engine, short block, whether it's a small block Ford or Chevy, or big block Ford or Chevy, and they've compared a series of heads. What I would say is, if you went back and looked at that data, what you would realize is that not the head that flowed the most off a flow bench was not the one that always made the most power. Because like anything, a flow bench and flow numbers are just tools that we use, like we use a dyno or anything else. It's just another tool to give you an idea. But really, there's mathematical equations for that. There's cross-sectional area, port volume, and valve diameter, and those kind of things based off your bore and stroke will give you a mathematical sort of, hey, this is what the cross-section should be, and this is what the valve size should be. And then there's percentage of valve size to valve seats and throats and those type of things. So again, what I'm going to share with you is just tools. So with that being said, my journey once again started probably several years ago. I think 2014 or 15. I was combing for data. I was trying to find cam specs. I was trying to find head flow data, and there was none up there. So I said, well, hell, I went out and bought a busted head off of eBay. And my buddy has a flow bench, so I took it to his house. We flowed it. Then we did a little tighten up on the valve job. We also back cut the intake valves, did a little bit of throat work, and picked up a few numbers. I'll show the head flow numbers here in a little bit. And then out of shits and grins, I threw the rubber boot on. I threw a stock throttle body, and yes, it was an 08 or 09 head I had, and I threw an older throttle body because it's just what I had, but it will still show flow characteristics. So I threw on there, and there was a drop. We lost about 20 CFM at 3 and 400 lift. So in my mind was, okay, the throttle body's restricting flow. So with that, what that meant to me is that that throttle body was a 44 millimeter throttle body, where the throttle body and the blades and the throttle shafts pass through, actually reduced to about a 37 millimeter actual diameter where it crosses through that section. So I said, hey, if we can make that a little bit bigger, we might pick up some flow. And so sure enough, we did. I sent off a throttle body to Max Bohr down there in Sanford, Florida. He took it up to, I think, that one to 49 millimeter, and put it back on a flow bench, and we picked up all the flow numbers that we had lost. So basically what it was, when you took a bored throttle body, you matched the rubber boot to the head, we were flowing as much with the board throttle body, boot, and head as we were with the head with no throttle body. So to me, I was hoping that was going to produce some type of gain. So I bought one for my motorcycle, put it on there. I gained a little bit, but certainly the cost of the throttle body, the tuning time, those kind of things wasn't worth the couple of horsepower that I picked up on the top end, from a dollar standpoint. So with it, I did that. I did it to another buddy's bike, and again, same results. Picked up a couple of horsepower, but it wasn't what I was hoping it was going to be, and so that's where we're at. So what we're going to do now is I'm going to transition into a slideshow that has a little bit of data on there. Hopefully that data provides a little bit of insight onto where victories stand, stock, what they look like with a little bit of port work, what do they look like compared to the M8. Now, this is not a M8 versus victory or Harley Davidson versus victory. This is just information. The engine is a giant air pump, and if it's 107 cubic inch Harley Davidson, if it's 106 cubic inch victory, regardless of bore and stroke, those things make very little difference under 7,000 RPMs. You can talk about bore and stroke configuration, whether you want to have a short stroke and a long bore, and things like that. So it's an air pump, and so those kind of things are comparable when you look at comparing things. It's like you can take a small block, you can take a 351 Ford and a 350 Chevy, build them with similar heads, same compression, same intake manifold, same header design, and they will make the same power within 1 or 2 horsepower. It's been done numerous times. Likewise, you can take Ford came out with a few years ago. Dart came out with a big bore short deck Ford short block. You can take up to 363 cubic inches, and then Ford took and de-stroked a 351 to 363 cubic inches. So you had a big bore short stroke short deck 363, and then you had a long stroke smaller bore tall deck 351 363, and they put the same heads and camshafts in, and they made the same power. Again, that's just the way it is. It's an air pump. So the comparison I use for the M8s and head flow and the victory is just a comparison to give us a point of reference. Okay? All right, let's transition. All right, we're back. So basically what we're going to do here is I got about 2 or 3 slides and a couple pictures I'll throw in there, but we're just going to sort of talk about the meat and potatoes of what the victories flow stock, what they flow with a little bit of increase in valve size and a little bit of port work, and then what do they look like with bigger valves, and then we're also going to compare those to the M8s. Okay, thank you. On the first slide, on the left-hand side is we have a stock head. That's with 36 millimeter intake valves, and it's actually 30.5 millimeter exhaust valve, dual valve. So we have 2 intake valves and 2 exhaust. And those are the head flow numbers, and those numbers do flow pretty good, but they're not great. And those numbers I'll tell you are a little bit better or comparable to if you're a 454 Chevy guy or a Ford 460 guy. Those numbers flow a little bit better than the truck 460 heads or the truck 454 heads, but certainly not what we consider like in the Chevy, that'd be the oval port head, not the rec port head. And they're probably down 25 or 30 CFM to a 5.3 liter 327 LS engine, the newer Chevy stuff. Whereas, like I said, our 106 is a 424 cubic inch big block if it was 8 cylinders. So those numbers aren't too bad. Then on the right hand side of the column, what we have here, there's a typo up there. So at 300 lift, that should be 245, not 145. But on the right hand side, this is with 38 millimeter valves and 31.5 or 30.5 or 31 millimeter exhaust valves. These heads were done by Star Racing. George Bryce, who again, longtime NHRA team owner, 40 years in the business, and so had a set of heads on him. And this was actually Steve Lowry, who was another longtime Victory guy who after seeing some stuff I was doing with the head stuff back in 14, 15, bought some heads off eBay, took them to George Bryce, and George Bryce sort of see what he could do with that. So if you look here, if you compare the stock intake and the ported big valve intake, what you'll see here is that there are CMF flow gains at every level, except for at 100-inch valve lift. So with that being said, what the ported head should make more power because it flows more. CFM or flow will tell you how much power you can make, and then you use your camshaft to dial in where you want to make the power. So I'll say it one more time. Your head flow, or the flow potential of the heads, determines how much power you can make, and then the camshaft is used to where do you want that power. Do I want a short cam and make a lot of bottom end with that good flow, or do I want something that makes more higher end horsepower? A little bit more on that during the recap, but there's a comparison to it. If you look at the exhaust side, when we picked up 60 CFM at 500 lift and 90 at 400 lift, so just things to take consideration. Okay, thanks. Next slide. This slide, now we're starting to get into something a little more meaty. So the head on the left-hand side, which is a Victory head, this was Steve Lowry's head that he put on his vision. His vision, with all else being the same, with only the change from the head, he had a 116-inch vision that was done by Kyle and KMC years ago. And that bike was down a little bit on power. It was a 128 torque, 128 horsepower. And normally, like, those visions are sometimes up over the 130 range. But anyway, Steve had the heads done by George, and then Kyle went down there and they put the new heads on the same configuration that he had before, and Steve went over 141 horsepower with those heads on there. On the right-hand side, what we have here is the same setup. So this is a stock M8 head. So on the left-hand side, this left-hand side has 40 millimeter valves, titanium, a lot of port work, oversized exhaust valves. And on the right side, we see a bone stock M8 Harley head. And you look how much that flows. There's a reason why, if you compare we'll call it a 114 Harley Davidson engine, they make comparable power to our big bore kits, our 116s. But they do it with a lot smaller camshaft. Because that thing flows so much, it doesn't need a big camshaft to make power. So it can have a smaller camshaft, will get you really big, strong bottom end. Some of these bikes are stock bikes with a cam upgrade and exhaust upgrade and intake that are pulling 120, 125 foot-pounds of torque at 2,500 RPMs, 140 foot-pounds of torque, and then 120 horsepower. But they're doing it with a camshaft that is not much bigger than a Victory stock camshaft with a little bit more lift. So again, when you just look at comparisons, pretty impressive on that. So two similar packages, head flow potential with the Victory on the right-hand side and the M8 stock M8 head on the Victory on the left-hand side and the stock M8 on the right-hand side. In this picture here is we're actually flowing the exhaust side, and I'm using a head pipe off a V92. So what you want to do is you want to represent how that's going to flow, and you use that, so you use a portion to provide a transfer where the exhaust valve is flowing not just into the open air, but flowing like you would through some type of header pipe. On the next picture here, what we had to do is make a jig to open both valves at the same time and same rate. So when you're flowing heads, you want to be able to set that for 100s lift, 200 lift, 300 lift, 400 lift, and so you screw that down until you get that right measurement, and be able to flow. And then on this one here, this is the 08, 09 head using an older throttle body off a 06, 07. But what we did is, once again, representing the full intake track, or at least a good representation, at least of the throttle body. So throttle body's on there, the rubber manifolds on there, and then also we put modeling clay on there to make the transition, which just smooths out the air as you're flowing. All right, let's recap this thing. All right, just sort of got done reviewing the video, and yeah, I had to have a few gaps in there. I couldn't even count them all up. But I just want to sort of to hit on a couple things a little bit. So when we talk about head flow, and head flow is potential, and there's a form up there that gives you an idea of how much power you can theoretically make, and it basically takes about 2 CFM to make 1 horsepower. And then you get number of cylinders and so on and so forth. So that's theoretically, that's what you can make in there. Then yeah, you can make a little bit more power. You can certainly make a whole lot less. That's sort of how much power you can make. Now, with that said, is you use your valve timing to sort of predict your power band. And if you don't flow a lot, you run buried camshafts. So if you guys want to do your own homework and you're into this kind of stuff, right? So what you can do is you can go to Stan Weiss head flow, tons of head flow data out there. Stan Weiss is everything from any make and manufacturer of automobiles and motorcycles. People have posted head flow information. So if you take a look at 88, 92, like I said before, the 88s, the 96s, the 103 twin cam stuff, you'll see they just don't flow a lot. They don't flow, they flow that, 190, 220 CFM unported. And so if you look at the camshafts that Harley ran to try to make power, they ran some pretty big camshafts. It wouldn't be uncommon to have a 240, 245 duration, 500 lift, 550 lift camshaft in a twin cam and still only make, 95 horsepower because the heads just don't flow. And so you run more camshaft to try to make up for your heads not flowing. Well, with our Victories, our heads flow better, but we still run some pretty big camshafts. And so we also run what's called a reverse split camshaft, which is, I gotta believe it has something to do with emissions, because reverse split camshafts are a camshaft that has more intake duration than exhaust. And it was sort of popular in the early turbo stuff for the 4-valve motors. But what people realize is that you can make more power with either a single pattern, which means your intake and exhaust durations are the same, or a split where you have more exhaust and duration. And yes, you can talk about intake flow to exhaust flow ratios, but that never really panned out. So I'm not really sure what Victory was doing with that, and I think that's the way their camshafts were. And it looks like the aftermarket sort of went in the same direction, and that, I'm assuming cam designers have a reason for that. But with that being said, when you look at intake duration, your intake duration sort of dictates where your power band is going to be. And so, like the camshaft I have in my cross country is a Andrews 472, and that has 242 degrees of duration. And my bike, she's 119 horsepower and 123, 124 foot-pounds of torque, somewhere in that ballpark. 106. I got good exhaust on it, good air filter, great tune, and I've run tons of exhaust to get there. You go to a 107 Milwaukee 8 with the good flowing heads, and they are making the same power off a camshaft with 204 degrees duration. So if you understand duration of camshafts, I'm running a 242, and my bike only flows 250 CFM. So I'm running a 242 degree duration camshaft with 472 lift, and a 107 cubic inch Harley M8 is running a 204 degree duration cam 470 lift and making the same power off the same cubic inches because the heads flow so much better. When the heads flow really good, you don't need a big camshaft to make power. So anyways, just sort of want to recap that. And again, this is not about Harleys or Victory. This is about engine airflow and how do we make power. So hopefully this is something that's sort of you enjoyed it. I like to do some of this kind of stuff. Not super technical, but I think for those who may be looking for a little itch on Victory stuff, that sort of scratches you back with that need for data. All right, okay. So last closing remarks. This is just information. What I ask you to do is don't like run up to the Vic shop or to Lloyd's or anywhere and say, hey, I just watched this video from Corey and Corey said I need ported heads. No, Corey's not saying that. What Corey is saying is there's ways to make power, right? On it. Now, and this is just information, right? I'm just sharing stuff that I learned. Now, I will say this, and this is not, I'm not advocating. The Victory world is probably the only world from a automotive hot rod standpoint. You know, there's a normal sequence of events when you build power. Okay, first thing you do is you do some type of exhaust. It always is, right? I don't care what you have. You bought a '65 Mustang, you throw some cherry bombs on it. This is what you do, right? Once you get your exhaust sound, then you'll upgrade from a 2-barrel to a 4-barrel carburetor, or from a stock dual plane to a RPM air gap dual plane or single plane, right? So you'll do some type of intake upgrade. And then the next thing you do is camshafts. And then after you do camshafts, you do heads. And after heads, then you know, do I need more displacement? Now, again, I'm not saying this is what you need to do for your Victory. What I'm saying is that's just, if you're a gearhead, you know how this works. Now, in the modern world, the heads flow really good. So what you do is you throw boost on it. But just saying, in the old school hot rod, there was a sequence of events: exhaust, intake, camshaft, head flow, and then displacement. But our heads aren't too bad to start with, and so we've jumped around. And the other thing is there's a dollar cost association with that. Unlike a Harley or your small block Ford, your big block Ford, or your GMC, whatever the case may be, your Mopar, pulling heads is pretty easy. With ours, we got to drop the whole engine to pull the heads. But you know, airflow, and I don't mean just a flow bench airflow, but you know, the right size valves, the right shape ports make power. And when you got good airflow, you don't need to have as much camshaft, so you have big, powerful bottom end on there. So again, not telling you go out there, you need to get your heads done. I'm not saying that. What I'm saying is, you know, hopefully this is some pretty cool information and you guys enjoy it. All right. Thanks a lot.